But ladies and gentlemen, the reason why we did what we did today is because I wanted to first make sure we all knew how to set up using a table to graph functions, because we are going to go back to graphing quadratics and cubic functions. But today we're going to focus on graphing linear equations. Now, I didn't give you any linear equations because we're going to learn an easier way to graph them, just like we're going to learn easier ways to graph quadratics and cubic functions, rather than doing the table method. However, I wanted you guys to go through all of that work and all of that effort of creating the table of values, plotting all the points, so that you can understand it doesn't matter what function or equation you're being asked to graph, you can always use a table of values. You can always use a table of values to graph. OK? Always use a table of values. So if I wanted to graph this, I could easily set up a table of values and say, oh, here's x, y, do -3 or -2, -1, 0, 1, 2. And you'd plug in those values for x, and you find the y's, right? But the nice thing about linear equations is that a linear equation is a line, right? It creates a line. So to graph this, we don't need to plot all those points. If you guys noticed, with the quadratic or cubic, to kind of get the shape of the graph, we needed like all of those 5 points, right? Or 7 points. Because sometimes you're kind of confused on what exactly was the shape of the graph. So we needed to use all of those points. Yes?
Does it matter if you use, like, if you use 0 and you set 1 to does it matter?
It doesn't matter as much for lines. However, for quadratics and other functions, it actually does matter. And when we get into that, I'll explain why it matters. But for right now, you can just always use a basic table. But once we get into quadratics, using the table of values that I give you might actually be harmful, might not work. But we'll go over strategies on how to choose the right table when we get to them. But for right now, if we're just looking at a table, we only need 2 points. So why go through this whole method of doing this when we only need 2 points? So I want to go through with you guys how to graph using slope-intercept form. And that is when your equation is set up when your y variable, or your value of y, is set equal to mx plus b. So an important thing you guys need to remember is this is our y-intercept, and this is our slope. All right? And I really want to make sure everybody understands, just like domain and range, what is the difference between the y-intercept and what is the slope. First of all, the y-intercept is a point. It is a coordinate point on the y-axis. So when I give you the point, do not go on the x-axis. Do not go left or right. It is up or down. Here's 0. If it's positive, you go up. If the y-axis or y-intercept is negative, you go down. So this is a point. The coordinate point is 0, comma b. The x value is always 0. So you're just going up or down from there. OK? The slope is a ratio. And we've talked a lot about ratios, especially for those ACT, SAT problems. It's a comparison. You are comparing the change in the y values, which sometimes we'll call run or rise, over the change in the x values, which we'll call run, between any 2 points. Now, here you can see that I have my y-intercept as -5. So that is 0, comma, -5. So I go and plot that. 1, 2, 3, 4, 5. So I've plotted my y-intercept. Now, the slope, again, guys, is a ratio between the change between any 2 points. We only have 1 point. But we can use the slope to help us find the next point based on that ratio. So when you guys are looking at slope, remember it's a ratio. So you want a fraction. This is 3. This is not in fraction form. So to put it in fractional form, I'll put it over 1. Now, if I think about this, we're through. The change in the y values is +3. That means between any 2 points, I have a positive change, which is 3. So I go up 3 units on the y-axis. The change in the x values is +1. So on the x-axis, I'm going to go over 1. OK? That is going to produce my next point. Now I can connect those 2 points and create my graph. Anybody have any questions? Yes? I'm sorry? Put it here? Yes, but what I'm trying to say is, remember, it's a comparison. It's the change between any 2 points. So to go from this point to that point, I have to go up 3. To go from this point to the next point, I have to go up 3. 1, 2, 3. I have to go from this point to the next point, I have to go up 3 over 1. So your slope is always the same. It's just telling you, hey, how do I get from one point to the next? The change in it is positive 3, so you go up 3 over 1. I know it started negative because that's where the y-intercept started. So it's OK if you start negative, but to get to the next point, you have to go positive 3 and positive 1, which is up and to the right. Make sense?